Thank you, everyone, for your patience. Turns out my laptop ran out of battery, and I don't have my charger with me. I hope nobody else in the room ever has that problem again. It means a few of my liner notes aren't available to me, so there may be a little bit of ad-libbing going on at the beginning, but that's okay. So, welcome. I know lunch is coming up, so I will do my best to be on time so you guys can get some food in your bellies. I know it's been a hopefully long and fruitful 3 days, and I hope you enjoyed the whole conference. So my name is Ken McKnight. I'm a solutions architect, which is a fancy way of saying a sales engineer at Electric Cloud. And what I'm going to do today is talk about data-driven DevOps, but not just data-driven DevOps, but about how you can take action with it. So I think you would agree that data is everywhere. You've got data in how you do builds, data in how you do deploys, tons of data when you do testing. So everywhere in DevOps, you've got data. I think the real challenge is how do you make that actionable? How do you take that data and do something with it that can automatically help your system rather than, I know all you guys love to get up at 2 a.m. and fight tickets early on and on weekends, you know, there's nothing better than doing that, right? But maybe perhaps there's a better way of doing it. So along the journey, I wanted to start with this idea of there's a ton of data. And we want to collect it, we want to collate it, we want to know how to use it in a way that that's going to be useful to us. So I thought I would give you a few strategies. There are tons of them out there, but I thought I would start by giving you 3 strategies that I think you can take home to your desks, and I know you are missing your desks. You really want to get back to it because the conference is, the conference is super fun, but being back at your desk is where you're productive, right? So 3 things you can take. I know, I saw that grimace right there. Yeah, exactly. So 3 places to look at. 1 is visibility, knowing what's going on, right? It's key. You got to know what's going on in your system. How are my builds doing? How are my tests doing? Have I got my deployments out on time? Really key, right? Pretty obvious. But taking that same data and making it actionable means that you can produce a system that can do things like heal itself, expand the number of resources you're using to make your tests go faster, or at least meet the SLA that you have. And one of the ways you can do that is with something we call smart pipelines, and I'll tell you all about that. And the third one, surely, is when you're looking at trends, you're looking at the reports, you're looking at the data itself, there are going to be places that stand out that for optimization. How can I make the system better? How can I make it faster? How can I make it smoother? Get my releases out the door because, you know, that's the name of the game, right? If you haven't got your product in the hands of your customers, you're not making money. So let's start with visibility. So everybody should recognize this as a sort of standard pipeline. You're doing your dev and CI stuff. You do QA, you deploy it, you release it. Ultimately, it gets out in operations and off you go. And you might guess, it's a little hard to read. I apologize. You'll get the slides so you can read this a little more. The contrast is a little tough. But in every single stage of your pipeline, there are so many data points and so many metrics and so many key performance indicators, right, KPIs, that you can generate. If you build it out, it's a huge amount of undertaking. And so when you look at this and you start to look at it over time, you start to recognize things like cycle time, like visibility, like scale. And the challenge here is how do you collect up all this data? How do you make it actionable? So for instance, if you see at the bottom here, we've got cycle time. It shows up several places, right? There's cycle time in Dev CI. There's going to be idle time sort of equivalent, et cetera, as you go down. If you think about it, there's a lot of points, a lot of tools involved in this, a lot of environments. I have to clean up my workspace. I have to get my code. I have to build my code. I have to test it. I have to build my installer. All of those pieces and many more, right? I have to check for security, et cetera. All of that information needs to be gathered, collated, aggregated. Now, that's just one example. What do I have to do when I have to do all of these? It's a huge effort to do. And along with that, how do I know what it impacts? how do I bin all this information? I might get Selenium test information back. That's awesome. What phase was that in? I don't know. It just gave me data back. I need some way to figure out where it is and how it affects me. So my thought is consider doing some intelligent data mapping. What does that mean? Well, you could do it yourself. You could write up scripts. You could put correlation together. You could do analysis. You can do reporting. You can do all that yourself. You can bring in a whole mess of tools. You can bring in Hadoop. You can bring in Splunk. You can bring in all that. That's awesome. Or you might consider doing it with something like an off-the-shelf tool that does it for you. So what it does is effectively says, hey, when I'm in a particular stage, the information I collect, I'm going to store and I'm going to know what it's all about. I'm going to know what context it's in so that when I ask myself, how am I doing? Am I, pretty optimized? Do I have any ways I can take that same data and do some actions on it to be more automatic? With this in mind, yeah, you can. So obviously, data is wonderful for visualization, and visualization is important. As humans, we need that, right? If you hand me a big JSON file, I'm like, that's cool, but not particularly illuminating. So with the concept of taking that data and mapping it, then what you start to get is the ability over time to look at all the different phases and decide, where are my bottlenecks? Where do I need to improve? That red sure stands out. That seems like a bad thing. Red tends to be a bad color, right? And something isn't trending well. Okay, so I might need to drill down into that and understand better what's going on with that piece. And the fact that you've taken this intelligent mapping, you've figured out where it goes, means I can now tell within my process what's hanging up. Maybe I'm awesome at defining all the enhancement requests. In fact, I am awesome at doing that. I can create 50 enhancement requests in probably 5 minutes. The problem is you got to get development to actually work on them, right? And if they're behind schedule, that's a problem. So that data there really provides that visibility, that ability to look and see where the bottleneck is and then make adjustments. Of course, that needs a human touch, right? That's not... Until AI gets to be so good that it can tell me what my job should be, I'm going to consider that to be a human effort. And of course, visualizing data is key. So once you've visualized it, how can you start to take it and put it into your automation to make it more predictable, repeatable, and less human interactive in terms of places where you don't want to be, like up at 2 a.m.? So what is a smart pipeline? Okay, I admit, whoops, I touched my mic. I admit I created that name. It's just, something that I thought of. And in terms of what is it, it's, to me, 3 things. One is it's this basic ability for your pipeline, or to be able to trigger a pipeline in response to a data event. Some obvious things might be testing's not going well. Should I continue moving forward and doing another 12 hours of testing based on the fact that my data proves to me that this thing is not good? I don't think so, right? That's an obvious example. I'll show you a bunch of other ones that you might not have thought of, or you're thinking, I wonder if that's a good idea. So hopefully Ken can show you that. It includes conditional execution. So what does that mean? It means as you're running through your process, it's not entirely rigid. If there's something in the process that goes wrong, the data can help me decide what path to go down. So it's not as rigid as just saying, I got to do A and B and C. What if there's a D option that might get me back to a working state? Wouldn't I rather have that in place than have to halt everything and start all over again? So Smart Pipeline's able to do that. Take the data, look at it, and conditionally decide, I don't want to go this path, I want to go this path, because this'll fix it. Or at least it'll terminate it in a nice way. The third one has to do with approval gates. The concept of taking stage-to-stage transitions and not only making it human-oriented, but also making it based on the data that you get. The example I gave around testing is a perfect one. Say you have Selenium or SonarQube, and you run that. You could have a person stop, get an email, take a look at it, and say, yeah, 98% passed. Looks pretty good. I'll let it go forward. But what if they're on lunch break? We do allow lunch breaks, right? Occasionally for our employees. Yeah. So, what if you're on lunch break? That could be an hour. right, of time, valuable time that could be used by the next person downstream to get their work done. So why not take that exact data and allow us to flow through the system in a more automated fashion? So I'm going to show you a few examples. I kind of beat this one to death already, but you get the idea. For instance, SonarQube might have a certain number of issues. By providing a pipeline that's optimized with this kind of data visibility, you can do a comparison. You can say, look, maybe I'm a little lax. 38 seems a little high, but let's say 38 is low for me. So maybe 40 issues or below is okay, and I'm going to let that on through. So I run my tests, I gather my results, I store them somewhere that represents intelligently mapped where I'm at in my process. And then what do? I compare it. Sometimes it's simple math, sometimes it's multiple things I'm checking. Was it a certain kind of test? Is it a minimum test? How much of it passed? And if that all works out, then I can automatically approve it to the next stage. So you get a little bit additional automation, a little bit faster throughput, and all done automatically. So what about the other end of the spectrum? So, we talk about sort of the front end, doing our dev and CI piece, going into QA and so on. But what happens when we get all the way out to production, right? It's paramount that your production never go down, right? Production down means loss of time and money. And so if you look at the other end of the spectrum, you might take the likes of Nagios or AppDynamics or Dynatrace, any of these APM vendors or monitoring tools, and you might look at it and run it and say, what's the health of my system? How is it doing? That's pretty good when it screams red at me and an IT guy or DevOps guy goes, oh man, that's a problem. But wouldn't it be even better if you could take that data, decide that means I need to kill a process, means I need to generate more instances of my Docker containers to handle the load because I'm swamping the set I have already. Take that, send it back into a pipeline and say, hey, I got a problem here. Production is not going to be happy camper for much longer. What can I do instead to self-heal, to basically get me back to a place that I'm happy with? And that might mean rolling back the latest and greatest. Maybe the change you made functionally works great, right? It's passed all the functional tests, but it turns out once it gets to production, it doesn't perform so well. After 2 days, it's starting to now leak memory like gangbusters. This is a way that you can keep your system performant, roll it back, do the analysis, and know that your production is not going down. So along with risk mitigation, which is kind of what we've been doing, right? If we ever have a problem, we can go in and self-heal. We can roll things back. What about compliance, right? Compliance and governance is huge. Same sort of thing. It's very well data-driven. I think Manuel in the last talk mentioned FinServ and all the data. You guys may not all have been here, but that in that realm, you have audit galore, right? In a regulated industry, you've got to be able to show what your audit is like. Well, when it comes to compliance, you may be using an ITSM tool like ServiceNow or Jira Service Desk or any of several others as part of what you need to do your job and do it correctly and have your chain be compliant. Well, in that case, use the data that comes out of your pipeline system to say, hey, I need a ticket. And during that ticket process, you properly fill it out in a compliant manner, you approve it, and it sends that back into the pipeline and says, you know what? You don't have to use the native function of that pipeline. You can use an ITSM tool and basically cause the either rejection or acceptance of that and move forward. So in a way, that data also helps support your compliance and governance efforts as well. And it's a best practice, right? If your best practice is to use an incident management tool, why try to force yourself into something else? So as we talked about compliance and governance, kind of along the same lines, there's the sense of security and vulnerabilities, right? You want to be able to, let's say, for instance, you're in a containerized world and you're a big fan of Twistlock. That's one of the security scanning tools you can have. The idea is, once again, that you're injecting that security scanning as early as you can and as often as you can in your pipeline. You mandate it, and when the data comes back and says, Yeah, you know what? You have 2 security holes. Bad news. Send it back to development to go plug those holes. You want that to be done as early and as often as you can, because once it's in production, you're in big trouble, right? So the combination of running your security tools early and often and having notifications when there are violations make it so the feedback is quick and it's relevant and it gets done way earlier than when it gets into production. So scan early, scan often. As I've hinted, there are a lot of places where mitigation comes in, right? I want to mitigate my risk. I want to make sure that I know that I've got at least a couple different exits, right, around the room here to be able to get out in case of fire, right? So the same sort of thing applies here. You might have a bulletproof process to get you all the way out to production, but there's always some risk. Something might happen. Somebody trips over a power cable and explodes one of your servers. That is not something you plan for, right? Maybe you've got backups. Maybe something else is happening. The idea here is to look at the data. So if something fails catastrophically in a way that you had not planned for, one of the keys to deployment side of things is to look at deployment strategies like rolling deployments, like blue-green, like canary. So the different styles then give you the ability to shift back to an existing system that was already running a version that was still perfectly fine. Maybe didn't have the latest and greatest enhancement, but the idea here is, for instance, blue-green means you can be upgrading an offline set of hosts to your new system, while the old set is still taking traffic. Swap them out. If a disaster happens for whatever reason, you've got an ability to swap it back and instantly be up again. And that's key when you're doing deployments, especially in mission-critical products, which, you know, when you're generating money, I suppose is all of them. So it's a process-driven mechanism, again, based on data. Some data might be somebody yanked a plug, network is down, data center isn't working, I had an earthquake. Could be something like that, or could be something as simple as, wow, this new function is now killing my servers for whatever reason. The data here then allows you to kick back into that pipeline and run that blue-green switcheroo. Get yourself back to a working version so you know your production system is safe. Right, always have a plan B. So we talked initially about how data helps you visualize and helps you as a human be able to notice trends and be able to make adjustments. We talked about how that data can also be used to drive specific actions that make your life simpler, better, more efficient, and keep your system humming. So the third thing to think about is optimizing your orchestration platform. So what does that mean? It means looking at the kinds of functions that happen within your system and looking for trends that you can use to produce a more optimized path to production. Because if you think about it, what's key is not where it's, well, let me see, for you guys, where it starts and where it ends, or not where it ends, but where it starts and how long it took you to get there. Right? Because if I can do a deployment in 5 minutes, that means that's the duration I have to worry about. You know, making it better than 5 minutes, that's a challenge. But what if it takes 2 hours, right? And then the next time I do a deployment, it takes 2.5 hours. The next time it's 3 hours. Something's trending in the wrong direction. And so we want to look at the data to figure out what is going on, because I don't like trending bigger. I like trending, towards zero. So a few different areas to look at. So first one, I think, is test duration. So by a show of hands, how many of you have challenges around how long it takes to run your test suite compared to everything else? That's kind of what I thought, right? Tests are, they're a struggle because you need them to make sure it functions right. You need them to make sure it's performant. You need them. And yet, they can be a large contributor to your overall process. So what can you do about that? Well, one of the ideas is taking a look at test automation in terms of the trends here that you're getting from your data, and looking to see what you can do if your test time is increasing. Can it benefit from more parallel work? So can you look at the system and say, you know what I'm noticing is if the number of tests coming through per minute doubles in size, I can see that if and it's a certain kind of test suite, I can see that by simply adding more resources, whether they're physical boxes, you just happen to have them sitting around, or even better, if they're dynamic, cloud-based or VMware-based on-prem type solutions, that you can start to increase the number of machines necessary to get your test suite through. So you can keep that threshold down. So it starts to grow, you add more machines, it runs it in parallel, and now your testing time comes back down again. That's not a perfect world. And obviously, there's some interaction between how you do as a human versus how you do it as a trend. But it definitely can help. Similarly, but in a slightly different vein, is this idea of deployment frequency and duration. So we talked about duration. The longer it takes, the more time you're wasting getting it out to your customers. But what contributes to that oftentimes is how often and how overlapping your deployments are. So you might start out with all your deployments beautifully in a line. You've got your calendar set up. They never overlap. There's no contention for resources. Guess what happens? Those pesky developers start making more and more feature branches. They start adding more to that whole pipeline. Now you start to get overlap. And what are you going to do with that overlap, right? How are you going to manage your SLA? Maybe it's supposed to be half hour to get a deployment out, and they're counting, right? Ops is counting on it being just that half hour window. Suddenly you're into 40 minutes. Why? Because some other branch came in and decided it wants to muscle in on all that resource. So again, taking a look at the broad spectrum of data and how you visualize it, what you can start to do, again, similar to testing, is you can start looking at the resource availability. Say that, for instance, if you have the ability to dynamically provision more resources, the pipeline, the smart pipeline, can take that data and say, aha, apparently I'm running low on steam here. I need another 5 boxes. I need them temporarily for quick 15, 20 minutes of boost to handle my performance. And then when it's done, it'll scale it back. So it's a sort of scaling mechanism, but done based on data that you've seen before. Same thing with concurrent deployments, but slightly different in the sense that it's not just overlap, it's what's the highest priority. So imagine you've got a hot patch. It's got to get through because I've got, maybe not production down, but I've got serious problems, and I know development can fix it with this hot patch. So the idea here is, by taking a look at what you've defined as the priorities within your system, you could say, look, if you're just chugging along doing a standard deploy, it's not really bothering anybody, and a serious hot patch comes through and it's got to be in there now, throttle the other ones, bring them back, slow them down a little bit, give me more resources, let me have that time to be able to get the critical thing through, and then bring the system back up again. So again, that data really helps drive those kind of critical decisions in a way that's more automatic. So you can concentrate on what you guys do best, in your field, making better process improvements, doing other work that's got higher value than having to monitor a system or bring down 4 machines over here and bring 6 machines up over there. Yep, and it's that historic data, right, that helps you with that. Because as you see over time, the trends are what help you drive that particular type of operation. So I hinted at what does it mean to help out in the likes of testing where I have a load and I have a number of machines and I want to add some more to it. So this goes into this a little more in detail, but I did it again. I called it SMART. Apparently SMART's a good word in my vocabulary. So SMART teardown. This idea, it goes into a little more detail about what do you do when you do have problems, let's say in testing, at any level, whether it's functional performance, scalability, whatever. If, for instance, you're using a cloud-based or an internal virtualized system, one of the key things I've found is that it's really easy to bring up a bunch of machines, run a test, and then tear it back down. Saves you money, right? And that works great if the test passed. Sweet, maybe I forgot the log file. That's kind of bad. I might want that for historic reasons. So maybe I need to do a little bit of smart work in putting the log files somewhere. But what happens when the test fails? You could just tear it down and send a report back to engineering and file a JIRA, you got a bug. That's not bad. That's a good minimum start. But consider how much effort the development team is going to have to go back into finding a machine and reproducing that same exact problem. What if you could have a bit more smarts in your pipeline to say, you know what, it failed. I'm going to not only send it to the team of folks who checked in that a bank of changes that one of those must have done it, but I'm going to give them the opportunity to hop on that box and take a look because it died. Why not give them the chance to do that? And then add some smart logic around timing. So I give you a day. If you want more time than that, you're going to have to request it. Otherwise, I tear that thing back down again. So the idea is, even though that dynamic resource is up longer than you might have wanted it to be, imagine the performance increase by having a high-paid developer be able to go in, identify that problem on a broken box without having to regenerate or reproduce it. It's already there. And then once they're done, tear it down and say bye. So I think it's really an interesting concept. Think about it. See if it makes sense to you guys in terms of adding that ability to what you're already doing, because I'm sure plenty of you are taking dynamic environments, spinning them up, doing the work, and tearing them down. Think about what it might mean to add the ability to your QA or development team to be able to see what went wrong and maybe debug it so that they can work on a fix. Yeah, I think it saves you time and money. Look at this. My timing is impeccable. It says 39, 38, 37. All right. So key takeaways, right? I talked about 3 strategies here. One around visibility, the data that helps drive that visibility. That same data through smart pipelines gives you action, gives you the ability to basically choose a more automated way and a more repeatable way. And then the last thing is optimizing your orchestration. So my tagline, which I can barely remember because I don't have my notes, was go out there and take action. Thank you so much. Have a wonderful rest of your day.